Today I'm going to be talking about building a data platform to scale data culture. But first, I'm going to share a little bit about myself, Strava, and our team. I'm Daniel, data engineer at Strava, currently located in Dublin, California, east of San Francisco. Favorite activity is trail running, so that's me in a trail race when races were a thing, and so were haircuts. Next slide, please. So Strava is the leading social platform for athletes and the largest sports community in the world. Basically, if you sweat, you're an athlete, and kind of we found the secret is really that people keep people active. Next slide, please. So Strava's mission is to connect athletes to what motivates them and help them find their personal best. So we'll connect them to, again, other people, challenges, clubs, and to be the record of the world's athletic activities and the technology that makes every effort count. Basically trying to be the journal to your active life. And so Strava is a global community, 78 million athletes. Most of them are outside of the US in many different countries. Next slide. 2 million new athletes every month, over 4 billion activities shared, and many millions each week. Strava started as a cycling-only platform. Most of our community today is still many cyclists, but the runners segment has really been growing. Also, a lot of people doing multiple activities to kind of change it up, plus a bunch of different activities. Next slide. Like many of the ones here, also very popular, the walk and the hike have come up. So with all this, what we basically get is lots of data. We've got about 200 employees. Both are growing very quickly. We've got both data in the product and specifically for analysis. We use that data to basically improve the athlete experience. And I think data being a key part of our product is also just helped us ensure that it's a key part of our business. So that brings us to data engineering. Our mission is to basically create self-service access to data and make sure that Strava's data set really becomes an essential component of the company. Next slide, please. Cool, thank you. We work with many teams across Strava. So sometimes it's more directly, sometimes more indirect. But primarily, we work with the data organization here. So that's analytics and machine learning. But we also work with engineering as a whole. So that's both product-facing vertical teams and the horizontal teams that support them underneath. And then basically anybody else interested in taking advantage of data. Like they're all different levels of different sets of technical skills, business context, use cases, goals, but this will include like the revenue, finance, CRM, metro teams. This brings me to kind of the core of my talk today is basically our journey towards building specifically a data platform. Starting from kind of the past, the problems that led us to focus on platform building, how things are going today, and then kind of what we see upcoming in the future, just in hopes that maybe our experience and learnings could benefit everyone, and really can't stress enough with the future that we're definitely still missing lots and there's a lot more we want to do. Starting with the past, just disclaimer is that Strava is a 12-year-old company and I've only been here 3 years, so this is going to be maybe a limited abridged version, but nonetheless, next slide, please. So we started as just the data team. Wasn't ambiguous yet with other data-like teams. Definitely a small team. Overall, just still narrowing down our kind of role in the company. Next slide. So yeah, with the warehouse, like many who are just starting off, we had like a MySQL reader instance off of our databases. Eventually did migrate to a Redshift cluster, which is certainly a big improvement as we could start joining multiple data sets and really have a real warehouse. But as we grew, we saw troubles scaling that cluster. Pipelines, we replicated data from MySQL. We had an in-house event tracking pipeline that used Protobuf and Kafka. We did try a couple analytics vendors, but we didn't really see the pricing models scale well for the volume we were expecting and just didn't necessarily tick all the boxes we needed. Pulled lots of third-party data in, which sometimes had issues due to there were just a lot to maintain due to like API instabilities and stuff. And then aggregated all this data with daily batch jobs. Yeah, this is roughly what it looked like. We had Luigi before Airflow, CDC vendor that replicated the MySQL data over to Redshift. There's the events pipeline that I talked about with using Protobuf and Kafka. And then, Looker on top of Redshift for the visualizations. So what we were seeing, especially as we grew, is troubles with data scale. Nothing fancy here, just queries took too long, they were failing, storage was getting expensive. But where we saw many of more of our troubles, I guess, next slide, was around more like the people scale side of things. And so in the beginning, basically all our ETL jobs were authored by a couple data engineers, and that also meant like we were maintaining all these jobs, and on call, was more about fixing these jobs rather than like maybe the underlying infrastructure or services, which could be good in some cases, but not this particular case. So yeah, and we just lacked the business context to like fix and deal with these jobs and know what we were trying to achieve, or the bigger context of things. So and exploration also became limited for our customers, because if we were the ones preparing these roll-up tables in Redshift, or the models and views in Looker, like people could poke around and explore, but it was limited to like what we provided. So in the end, there were growing teams, growing interest in data, growing interest in diverging data. Bottom line, like we were the interface for working with data more often than we'd like, and therefore we were becoming a bottleneck to the rest of the company. So, finally we got to catch our breath and really just take a pause and think, where are we spending our time? And really the last question of like, how can we scale with the organization as we really like jump into a lot of different data. So that brings us to today. We are still a small team, but we have made progress over the years, I think. Starting with the shift towards a platform. Let the platform serve the data needs. Our role as data engineers is just to build the platform and guide people through it. And wherever possible, use self-service. It doesn't make sense everywhere, but when it does, it's usually better for everyone. The service, I don't know if those are real, but basically both sides benefit. And yeah, components should be generic and flexible. You want to avoid solving specific use cases, but they should ideally solve categories of use cases. You want to avoid very specialized tooling for a particular data set, but maybe you can create specialized tooling for a shape or type of data. And so these attributes apply to different parts of the platform in different ways. So let's just start jumping into them. Next slide, please. Yeah, warehouse. Starting with a warehouse, of course, limited upkeep. We don't want to focus on how we store this data. We just want to focus on how we can get it in the hands of people. So yeah, of course, want to be easily scalable in storage and compute. Reasonable to store more data was important for us, because we really want to shift towards the ELT pattern because I think it simplifies loading. There's no special logic per data set and lets us unify transformations in the warehouse, which means we have less specific transformation logic in like each way we're loading the data. And then of course, batch and stream loading options always kind of let us expand our horizon. In terms of pipelines, breaking it up a little, starting with event tracking. These are like behavioral events in the app, the website, from the server. We really want to reduce instrumentation friction. Strava has a very wide feature set, and we really want coverage on all of them to understand how our users use our app, because all athletes are very different and what they want out of the app. So we want schemas that are event schemas that are easy to write and understand, handling bad data, obviously that's important, and minimize limitations in event volume. Basically, we were just trying to optimize for adoption and thorough instrumentation, so we really wanted to make that easy. In terms of loading data in, we just want to share as much infrastructure as possible, especially as that data moves closer to the destination and further from the source. And even as you talk with source types or different, like for example, S3 or FTP or REST APIs, like those interactions ideally should be reusable, even if you're talking to different sources. Next, with processing, we ultimately want to enable those with a business context to process their own data. They know their data better. They know what they need it in. They know what analysis they're going to do later, and even further potential use cases down the line. So, yeah, we really want to reduce, boilerplate setup, throw in scheduling, monitoring, alerting, just kind of for free, and really standardize on the common patterns, especially just like simple SQL jobs. So that brings us to this picture today, which, yeah, has more arrows. Yeah, basically, as you kind of look over these, you'll notice that we buy, build, use open source, like whatever we need, like we'll use the tool that's most fitting. So I'm just gonna pop through some of these. So starting with yeah, Snowflake, which is where most of the arrows are pointing to, which is not surprising, hopefully. The separation of compute and storage, auto-scaling multi-cluster warehouses, like a lot less managing of resources, just was a huge plus. In addition to semi-structured JSON data support, that really helps us with that ELT pattern. And then the Snowpipe for stream and copy into batch commands for loading data in. And then kind of going to the bottom left, we've got the kind of the old events pipeline, which we still use, but we limit it to server-side events that we kind of feed off of existing processes, so that there's no like extra instrumentation happening there usually. And then for most of our kind of events now, we use Snowplow, open source event tracking tool with a great team that backs it. It does schemas and JSON schemas, which is just easier to write and understand, even if you're not familiar with it at all. And it's got like Elasticsearch and Kibana integrations that make debugging those events in near real time, whether good or bad events, much easier. Next, going to the middle, back to the diagram. We'll be on here for a little longer. Thanks. To the middle section, we've got the Kafka to Snowflake infrastructure that we kind of built up. There's widespread use of Kafka at Strava. And so we really like this Snowflake Kafka connector that's kind of developed, I think, in the last year or two. We just made everything generic in terms of building this infrastructure because we know, I think this is going to be a common interface to Snowflake in the future. And we've used this for both webhooks that we get from other vendors, and also we've replaced kind of the CDC vendor with using Debezium, another great open source tool to get the changes out of the database and through over to Snowflake. And then a little bit below that, we have a data transfer tool that uses Spark to move data between sources and syncs, and we just implement the source and sync connectors so that they could be used interchangeably between our databases and Snowflake or elsewhere. And then closer to the top right section, we've got Fivetran we use for numerous data integrations. We got quite a few connectors, and there's just plenty we're eyeing. I think it's unique in that for once we're usually waiting on our customers to tell us when they're ready to pull that data in rather than the inverse. So that's been super convenient. And then top right, I've got Airflow Plus. I'll explain the plus in a bit, but yeah, I think everyone's familiar with Airflow. We just like it because there's the whole reusable operators, really like the dynamic DAGs as well. The plus is our own framework on top of it that makes it easier to write Airflow jobs in YAML. And the easier way to explain this now these days is we built DBT ourselves, and it was before DBT got much bigger. So definitely some regrets there. That's on me. But basically Airflow for common, especially SQL only use cases. It's powering hundreds of unique transformation jobs. We use it to alert on key metrics, report metrics to our partners, Slack bots. It's also part of our Metro product. Our Metro product is basically we have a huge data set of human-powered transport data, and we give those to like cities and governments for free so that they can improve their like urban planning and improve bike lanes and things. Finally, Tableau on the right, we did switch that out from Looker. Provides kind of high-level numbers to drill down analysis, mostly curated by our analytics team, and we're still kind of working through improved self-serve there. So that's the whole picture. Another way that we look at this platform is there are layers, and you can kind of hook in at whatever layer you want. So the view layer, you're just consuming the data. Interact, you're actually working with the data, and feed, you're moving the data in or out, data in or out. And we'd like to bucket our customers in this kind of way because it really makes sure we understand their like very unique needs. So this should look like some sort of reverse pyramid, and that like view definitely is the biggest bucket. But yeah, and so view, includes maybe you're just looking at dashboards, looking at like the report that a Slack bot sends. So just consuming here. Next, interact, maybe a little more involved. You're querying a Snowflake, you're doing some Spark analysis, writing some nightly ETL job. And then feed, this is again, both in or out of the platform. Back one more, I think. Yep, thank you. Yeah, so you're writing, you could write a job to load data from a source into Snowflake. You can instrument events that'll go into Snowflake, pull in data set with Fivetran, or you can also pull data out of Snowflake or off of some of our Kafka streams. And kind of the bonus layer we have, next slide please, is kind of extending the platform. And we've got our ML team building a framework around real-time consumption of our snowplow data, and some analysts have built frameworks on top of our DBT-like framework of their own like experimentation feature usage frameworks that other analysts and other teams can take advantage of. So that's been cool. Just to kind of talk through some, headwinds, things that slowed us down as we made this transition is, transition of ownership doesn't happen overnight. We needed to transition ownership so that we could have more of the business logic side so that we could focus on the platform. And even after we got plenty buy-in from everyone, it still takes time. Buyers are going to come up that we still need to jump on and take over. But yeah, migrations never move as fast as you'd like. I think maybe everyone's familiar with that. And pushing for adoption of tools take time and effort. It really has to be treated as it's like building a product. You need to sell, you need to seek input, trainings, lead by example, and then last, yeah, guardrails are still needed, especially with open and self-serve access. Some tailwinds, yeah, we definitely found the work more rewarding, and we felt like our impact was multiplying quicker. We had an arsenal of tools just cover unforeseen use cases that we learned. Again, comes from the flexibility and generic aspects of our tools, and kind of that bonus layer of seeing our platform extended by others was really cool. Yeah, finally, the future. A lot of paths we can take, around data democracy, getting the data into more hands. Centralized catalog is something I think we need to work on. Lineage, as the previous presenters talked a lot, really important in many ways. And just overall, more room for documentation. I think democratizing data is not limited to technical skills and access. You can't use the data if you can't understand it, know where it's coming from. So it means a lot of training, guides, and things like that. Next, data capabilities. Spark is something widely used everywhere, and including our product side as well. We definitely want to really push that further, especially on our like analytics and data side of things, and find ways to make that more accessible. Similar notebooks, we know a lot of people use it, how we can integrate it more into our flow, and take more advantage of streaming data. Data infrastructure, these kind of tie into the other 2 points, but like quality checks, again, sounds like maybe I should review some of the links at the end of the last presentation. Governance, very important, of course. And, we kind of use Snowflake as a data lake right now. But, I think there are definitely advantages to having like a proper data lake. Finally, just continue to develop the platform, to develop solutions, and stay in tune with our customers, be aware of developments in our space. Doesn't mean like jump on every new thing, but know like why they popped up, what issues they're trying to solve. And then I think every so often just rolling up our sleeves, and sometimes we have to help out with these, what we say, like not platform specific problems, but it really like helps us understand, build some empathy and understand what people are working through and the friction they run into. Yeah, finally, just kudos to all the data engineers out there. I think, as we've all got a lot of work to do and a long way to go to where we want to be, but just don't forget to look back at the progress that we've all made. It's always very cool. Even if you're just getting started, remember that, just remember the days like we didn't look at our data at all. So yeah, thank you for listening. Appreciate the opportunity. I think our journeys are both probably similar and very different in ways. So depending on context, priorities, restrictions. So hope it was still helpful. And of course, we're hiring, and specifically hiring data platform engineers. So definitely reach out.
That's fantastic. I really appreciate your conversation style. It was really, really fun to follow along. We have a couple questions that have come in. If you are game, we have about 5 minutes left. So is there a reason for using webhook options rather than Fivetran's webhook functionality?
Yep, that's a good question. I think some of it is just, I mentioned that Kafka to Snowflake infrastructure that we built up, that like once we get into Kafka, it's easy to get into Snowflake. And so and similar on the like webhook receiver, we've got, because we've got plenty microservices at Strava, it's easy to kind of build up an interface for that webhook receiver. And so we felt like, we've got plenty different uses for webhooks. It just works kind of right out of the box with our infrastructure. So we felt comfortable proceeding with our own.
Okay. I'd be interested in Daniel's take on the one big table versus star schema modeling question. And then, yeah, it gives a reference to a Fivetran blog post. But yeah, do you have any take on the one big table versus star schema?
Yeah, we've got experience with both, and in particular, um, half of our warehouse is taken up by one big table, and we're actually very actively running into issues with that table, and so I think we're still learning. We really do both in different cases depending on the data set, and um, I think in the long term, yeah, the one big table is just going to run into issues, but I think it's okay to start that way as you really understand, because I think if you break things up into too many tables too quickly, you may be doing that kind of, yeah, it may also just generate like messiness and becomes harder to join. So,
Okay.
um, yep.
A question not necessarily about a tool, but a little more meta. How do you see data engineering, sorry, how do you see the data engineering function transforming at Strava in the future? And is there anything that you're really excited about that would make your life easier?
Yep. Yeah. I think in terms of transforming, I think it's, right now we're just one team focusing on the platform, but I think kind of like I pointed out with our like future path, there's just a lot of different paths we can take. So I think maybe someday I could see it breaking up into more teams that focus on, maybe it could be different layers of the platform or just different interfaces to the platform. I think it can really go many ways. But I think maybe just having teams more dedicated to maybe a certain um, audience or customer, I think would be
Mhm.
interesting.
In your talk, you gave a lot of examples about how the process, the analytics and engineering data process has changed. How are business users more enabled now versus when they, 6 months ago or a year ago?
Yep, I think the main thing is like maybe they can't get absolutely 100% on their own, but I think like they really can get started without us, and um, there's oftentimes we're just completely unaware of how our platform is used, which not good in some ways, but that's awesome in others. That like we're really, I think, out not the bottleneck, or maybe just like last minute help or when issues come up, but we're really kind of pulling ourselves out of the equation, and the platform is serving, I would say, majority of our needs, and we're just there as like advisors and support.
Speaking of that, how has the data team evolved in job responsibilities over the last few years?
Yep. Yeah, I think it's again shifting from just direct interface with the data to
Mhm.
um, more pointing and showing people how to use a particular tool that we have, or um, um, yeah, really just support of the platform.
Yeah, great. One last question, then I'll let you go. Is there a plan to extend your current transformation or processing solution into DBT?
Yeah, I suspect that is the long term, and that's probably the wise path to take. I think I see a world where even our tool can be built on top of DBT, and we still like our interface in some ways. We really tried to make it as accessible as possible. So, yeah, definitely open option. We're definitely by no means tied to kind of the tool we built, and we really want to go with the best tool. So,
That's awesome. That's awesome. This has been a great talk. We appreciate your time. Thank you so much.